Hi, hi, hi. Okay, guys, third time's the charm on this video. I'm not going to tell you how late it is, but I'm having technology issues, taking one for the team. Okay, now this video is talking about chi-square again, but there's a certain type of chi-square in reference to when we use a two-way table. Now, there's two of them when we use a two-way table, but the one we're referring to today is the chi-squared for homogeneity. But before we get into the specificities of that and then comparing it to our chi-square goodness of fit, let's just remind ourselves of what a two-way table is. Okay, it's not about the dimensions being a 2 by 2. It's about comparing more than two samples or groups. So two samples, two groups, two populations, and categories within each of those groups or populations. Show you an example of that in a minute. So when we're looking at the idea of what is chi-square for homogeneity, first of all, with chi-square, we compare the distribution of a single categorical variable for more than two populations. So I want to slide over to this for a minute. So we have freshmen, sophomores, juniors, seniors. Hope you can see that S. Those here are for two or more populations. And then the category would be grades, specifically grades A, B, C, and we'll just stop there. So this is an example of chi-square for homogeneity. I mentioned earlier that the dimensions are not about it's not a 2 by 2. Here it is the number of the population and how many categories we're looking at within the population. I also mentioned the idea of ANOVA, and when it comes to ANOVA here, it's the same premise, but it's when you are using quantitative variables. And some groups are going to be doing ANOVA for their project. People that don't take the AP test, they have to do some statistics from stats too. So we will hear more about that. Okay, next, what is the test statistic for it? Well, the test statistic is exactly the same as it is for the chi-square GOF. One thing about this, though, for the chi-square for homogeneity, basically it's a big picture of the overall average. Whereas when we have done the a two sample z-test, it shows the difference between two proportions. Now, I just mentioned a minute ago looking at freshmen, sophomores, juniors, and seniors, A, B, C's, and D's. Well, A, B's, and C's. In order to use a two sample z-test on this, I'd have to compare senior A's to junior A's, or senior B's to junior B's, or senior A's to freshman A's. So that's the most I can do when I'm looking at a two proportion z-test. But when I have chi-squared, I can pull it all together and then do what's called a follow-up. We'll talk about that in a minute. Okay, as I keep going, the degree of freedom. Well, the degree of freedom are your rows, your row totals, the number of rows you have, -1, and the number of columns that you have, -1. So, like, I want you guys to, let's go ahead and look at problem right here. Okay, we'll read the scenario in a minute, but I just want to talk about what the degree of freedom is going to be for this. So here you see you have 1, 2, 3, 4, 5, and you have 3 here. So here you've got 5 rows -1, and then you've got 3 columns -1. So okay, so of course that's the 4 times the 2, which gives us the 8. So that is how we come across getting the degree of freedom for the chi-square for homogeneity. Now, how do we find our expected counts? Our expected counts is something similar. We find our row total and multiply it by our column total and divide it by, I refer to it as the grand total, they refer to it as the table total. You can see I've done a little color coding here. I don't know how well it shows up, but let me jump down to here, looking at what we have for the this problem, the Black, Hispanic, and white parents. How the expected count works. The expected count will be, they set the row total. So here I'm just going to be looking at the total of excellence. And let's look at excellent Black parents. So the row total is going to be 68. The column total, again, I'm looking at Black parents, is going to be, okay, your column total, which is 202, and then divided by the grand total, which is 605. And if your thoughts are, yes, this is a pain, you've got to do that for all 15 of these. But yes, there will be a shortcut, which I obviously will discuss with you. But this is how you find the expected count. Now, with all of that being said, remember, this stuff is going to be put in the calculator, and the calculator is going to do a huge amount of information for us. Okay, so let's remind ourselves of how we put it in. Okay, let me clear out of that. We're going to go to matrix, and I want to just change something for a minute. So to show you how it populates, so I'm just going to change this matrix just so it's not what it should be. And I can have it populate and you can see it happen. Okay, so here's your matrix. Go over to edit. And if you remember in class on Friday, we entered this information based on the values that we have here in our two-way table. Remember, two-way does not mean 2 by 2. It just means you have a population versus categorical. And remember, when we enter here is the row and the column when we enter the information into our matrix. Now, how can we calculate the chi-squared value? So I have this. You know you're going to have to pause to re-enter it just in case you don't have it in there anymore. Then I'm going to go to stat, over to test, and I'm going to go either up or down to chi-squared test. Remember, we're not doing goodness of fit. And then I'm pressing enter. Remember, here I entered the information in my matrix A. Next, I want you guys to, okay, you don't have to go back and look at this, but I want to show you something. Here, notice my matrix B is a 1 by 1. Let's see what the information is in my matrix B, whatever that is. Okay? Now, when I do these tests for the chi-squared, I do not, remember, I do not put anything in for the matrix B. I tell it to, I've keyed in the observed. I do not type anything into matrix B. I'm going to go down and then I'm going to press calculate. Now, yes, it gives me my chi value, it gives me my p value, which ultimately we know we need to make a determination if we're going to reject or fail to reject the HL. But I want to show you something that's really so cool. Okay, I went second matrix. Look what happened there. Remember, before was a 1 by 1. So this is why you don't put anything unexpected. It populates for you. It puts the information in there for you. And then I'm going to go over, let's just check out and see what's in matrix B. Look at that. Those are the expected counts. So remember how we, a couple of seconds ago, did the math on this? The 68 times the 202 divided by 65. Pause, do your math, and I can guarantee you that it's going to give you that value. So remember, nope, we don't have to do it for all 15. Unfortunately, we do have to write down all the values, but we don't have to do the math ourselves. And then you might want to take a minute to pause so that you can write down whatever you see here in terms of the notes. Okay, now go ahead and write down what you see right here for remembering our analysis. And I've got it, I can't pause. The puppy's driving me crazy. Check out there for a while. Oh, sorry about that. Okay. So here, remember when we're analyzing results, when we have categorical data, we should do follow-up analysis. Remember the follow-up analysis is each of those little cells. Oh, you don't remember that because I have to go back and remind you of what that is and fill in those notes. But here, let's complete this and then we'll go back. Okay, we're looking at what each of those values are. So in other words, the observed minus the expected squared over E, because we're seeing how each of the values of those, or how each of those literally help us to determine what the difference is or how it influenced our rejection. So we only consider it when it's rejected, because if it's not rejected, they don't care. Remember, the rejection is, well, they weren't expecting it to be rejected. They're saying, I know there's nothing wrong with it. You got to prove it. So when we are able to prove it, it's just like in a court of law when they poll the jury and say, okay, guilty, 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 trying to find out that one person that wasn't quite sure that person was guilty. This is, again, we're trying to find that one area that shows that it was so different than the other values, and that's what caused it to be rejected. But I want to go back to the prior page where it says here, what is a follow-up analysis of a chi-squared test? So I inferred this a couple of seconds ago, but let's restate it. When we reject the HO, one of the variables of the distributions of cells differs from the stated amount, which is what's happening here. So we look at that and see which of those are the smaller ones, and those are the ones that contributed to the rejection. So in the calculator, when we see CNTRB, that's saying contribute. That's nothing but the math. It's nothing but the math. Nothing more, nothing less. Of the observed minus the expected squared over the expected. But we look at that and we say, again, which of those values contributed to the rejection. And when that happens, quite often the values, there's one contribution that stands out, either very high or very low, that affected the outcome. So now let's go back again to the other page. You see, you hear her knocking. You're stuck out there, Cypher. Okay, so take a minute to read over this. Go ahead and pause. Okay, so the question, we have the three nationalities. They're looking at black, Hispanics, and whites. Their question is how the high school, how they would rate the high school as excellent, good, fair, poor, or don't know enough to say. So the first thing we need to do is calculate the conditional distribution of the response of each group. So in order to do that, the first thing we need to do is to get our information and come up with our row totals and column totals. Well, the reality is I have to do it anyway because remember I needed that to figure out my expected count. But here are my column totals for Black, Hispanic, and white. Here you can see are our row totals for excellent, good, fair, etc. And here I refer to it as the grand total, which is the table total. Now remember, we are looking for the conditions, which means the excellent, good, and fair, based on your parent group. So as I slide over right here, I'm looking at excellent over, so black parents that thought it was excellent, black parents that thought it was good, black parents that thought it was fair. So here's your excellent, the 12 out of the 202, the good, which is the 69 over 202, the fair, which is 75 over 202, and etc., etc. So what do you think we're going to be doing for Hispanic? Here, you're looking at, again, your total number of Hispanics is 202. So what do you think? What do you think? Yep, you're right. Excellent is going to be 34 over 202. Good is going to be 55 over 202. And so on and so forth. And now, what I want you to do is pause. Fill out the rest of this. Try to do it yourself for the white parents, and then see what happens. And check your answers. Okay? And here they are. Good job, ladies and gentlemen. Now, the next thing they want me to do is to make an appropriate graph. And I did this earlier, and I didn't want to do it before you. I wanted to do it with you. The tape, I had tape issues, just having technology problems. Okay, so this is how we do it. Here my percentages are here. Here's your 10, your 20, 30, draw it to scale. This entire area is going to be the black parents. And within the black parents, I have excellent, good, fair, poor, don't know. So let's look up here at our percentages. We have basically 6% that of African Americans, of the blacks, said it was excellent schools. So here, that's going to be about there. Then here we got 34%, so that's going to be about here. And you know it's not drawing the scale because I'm drawing it. So 37 is going to be a little taller than that. I should put maybe 40 about there. What you think? Okay, here 19. I'm sorry, 11.9, so 12, just a smidgen over. And then 10%, which is about here. So that's how I would draw it. And now I'm going to move that away so that you can draw the rest of them for the Hispanic and whites, but I needed you just to see where it came from. I have these symbols above here for a reason that I will be talking about in about a minute. Now, after you have done the drawing, I need you to read this last problem, and we want to do a comparison. Now, as we do the comparison here, had to let her in, she was scratching up past their bedtimes. We want to write a few sentences about the three groups. Well, first of all, I'm going to look at the excellent, and it looks to me like Hispanics, a greater percentage of the Hispanics felt that the schools were doing an excellent job. So that's what I said here. Hispanic parents are more likely to think that they're doing an excellent job. And I'll be honest, I should throw in a percentage there. Okay, then a good job. Well, here it looks like here the white parents feel like it's doing a good job, and that's what I said here. And you can see now why I put the little symbols there, so you can see the Hispanic. This confirms that this is the bar that I looked at in relationship to the other bars for the groups. And lastly, we can see here when we're looking at fair, black parents have the tallest bar for fair. If you wanted to mention the ones that felt it was the poor, you could do that too. I would not mention don't know, because that's not really any information. So let me slide this up so you can make sure to get it all. Okay, you need to pause, because now we're about to go to the next page. Now, as we look at page 7, page 7's question is, do the data provide convincing evidence of a difference? Well, that tells you what's coming up, a hypothesis test. Whenever we say, do the data provide convincing evidence? So they want to know if they're going to do this. So part A, what is my HO and my HA? Well, my HO, remember, is always saying that there's no difference. We're saying that there is no difference in basically how the black, white, or Hispanic parents feel about the schools. And of course, my HA is saying, there is a difference. And see how I cut it off? There is a difference in the given distribution. Next, here, the expected count. Remember how I said to you the expected, calculate the expected count. We know it's the row total times the column totals divided by the grand total. And here, we found it for one cell. We're about to find it for one cell. I'm really tired, so I've forgotten what I did. Okay, but let's see these numbers. So for this cell right here, for the black parents and excellent, well, the row is 68, the column is 202, and the grand is 605. So this is going to be the value for the first cell. That's for excellent black parents. And the reason I'm not sure if I already did this before, if I am, I'm being redundant, I'm sorry. Because this is the third time I've taped this because I've been having computer issues. The thing stopped on me and all this other stuff. So now, make sure this thing doesn't fall asleep on me. So you can see this is exactly what I have right here. And then, as I look at this value. I've done the math. They've done the math. The calculator's done the math. So, go ahead and fill out this chart. And I know your thoughts are, do we have to do this for all of them? Just this one time. And then next time I see you guys, I'll tell you how we're going to cut back. Because the bottom line is you do have to show the expected counts for all of them. And in terms of the actual row and column, you do have to do it for a couple of them, maybe 3 of them, and then after that, just write down the expected count. So, spoiler alert, I already told you what you needed to know. Now, here, our chi-squared. Remember, our chi-squared is our observed, which was 12. You can refer back to the other page. Minus the expected. Here is our expected right here. And we have to do that for all of them. But remember, we're not doing that. We're doing the first one. We're doing the last one. Or you can do the first two, whatever you want to do. Do 2, 3 at most. And then end up giving them the chi value, which you remember as I quit out of this. Well, I'm just going to do it again over here. Doing the stat test chi-squared. And here's your chi-squared value with your p-value of 0.4%. Number 32 is asking us, well, were the conditions and assumptions met? Okay, here we have 3 randomly selected independent group of high school parents. And I should add to it I should add Hispanic, white, and black because they were specific to that race. So please add that. Here our 10% rule for the 3 different populations. And all expected counts, well, the numbers are pretty big, or you can refer to problem 30. All the expected counts were greater than 5. I already mentioned this before, but the degree of freedom, given that you have 5 rows and 3 columns, is 5 minus 1. And 3 minus 1, which is 4 times 2, to give you a degree of freedom of 8. If you use your table, remember you can go over 8, and you're going to see these values, and you can slide up. So you can see your p-value is going to be between 0.025, 0.0025, and 0.005. But let's face it, our calculator already gave us the value. Remember, if you could do this, but honestly, nobody needs to do this. So here, our chi-squared CDF, we would need to do it if we didn't have to go through that process. But honestly, this is a waste. The waste of a table. 2, here's our value. Use it. You only use these 2 methods if you have no other choice. Next, they didn't ask me for the conclusion of the p-value, they asked me to interpret it. So assuming that the HO is true, assuming that there is no difference in the distribution of the opinions on how the high school is doing, given the above groups, there is a 0.042 chance of observing samples that show difference of opinions as large or larger than found in the study by chance. When you get a chance, speaking of by chance, here I'm saying the same thing, but I put it in more of a generic situation all the way down here, below this line. And as I wrap this up, now they're asking me finally for the conclusion. Well, I have a p-value that's less than my alpha, so I'm going to reject the HO. So we have convincing evidence to suggest there is a difference of opinion about how the high schools are doing given Black, Hispanic, and white parents. So that is the entire process. Oh my gosh, this video is long. So let me put a stop to this and bid you adieu. I will see you guys in class. Bye-bye.